You said we can use calculators, right? What about respawn?
That's more powerful than what you should. Can you find a TI 30?
Okay.
So we'll start in about 1 minute. We'll continue the test review. Damon, right?
Mm-hmm.
Damon? Yeah. I'm a slow learner. Scott?
Yes.
Zach? Brianna? No. Ariana? All right, it's time to start. We'll continue with the test one review sheet. So tomorrow, you're all going to stay home. Stay home. I'll send you a Zoom meeting invite. The meeting will start at 7:30 because I can't start it at 7:45. I mean, that's the scheduled time. And you can enter the meeting early. I'll let you start the test as early as 15 minutes till 8. At 7:45 if you want to start early. But make sure that you're in the Zoom meeting by 8 o'clock. And you also need to have your video on so that the camera shows your desktop or your tabletop where you're working on the test. Okay, let's continue. Yesterday we did number 19. We graphed the line that passes through the point -5, 2 with the slope 3/4. So we plotted the point and then found another point on the line by using rise over run. So we have from this point we have a rise of 3 and a run of 4, and we ended up at -1,5, and then we drew a line through those points. The next problem, number 20, this one says graph the line 3x plus 2y equals -2 by using the slope and y-intercept. Okay, if we want to use the slope and y-intercept, we can rewrite this equation so that it's in slope-intercept form, the y equals mx plus b form. So over here, I'll just write a reminder, y equals mx plus b is the slope-intercept, and we'll be able to know what the slope is. That will be the coefficient of x, the number m. And this number plus b is the y-coordinate of the y-intercept. That's why it's called slope-intercept. So we'll solve this equation for y. So I'll rewrite 3x plus 2y equals -2. Subtract 3x from both sides. We have 2y equals -3x minus 2. Then divide both sides by 2. we get y equals negative 3/2 x minus 1. Okay, so the slope of this line is negative 3/2, and the y-intercept is the ordered pair 0, -1. Okay, so we'll squeeze the xy plane in there. The y-intercept is 0, -1. So get into the habit of labeling your points. This is 0, -1. That's how I'm labeling the y-intercept. And then we have a slope of negative 3/2. We can use the slope in one of two ways. We can think of the number negative 3/2 as negative 3 over positive 2. So if we wanted to use negative 3 over positive 2, that means we have a rise of negative 3 and a run of positive 2. So from the y-intercept, a rise of negative 3 means move down 3 units. So the y-coordinate of this point is negative 4, because I moved down 3 units from negative 1. And then a run of 2, we move to the right 2 units. And this point is 2 for x and negative 4 for y. Okay, that's enough to get a graph of the line. But you can also interpret this slope, negative 3 over 2, if you want. You can think of that as positive 3 over negative 2. So if we go back to the y-intercept and instead think of the slope as 3 over negative 2, a rise of positive 3 from this point means we move up 1, 2, 3 units, and then a run of negative 2 means move to the left 2 units. So we also have this point on the graph. The coordinates of this point are negative 2 for x and 2 for y. Okay, so we did more work than is necessary, but these 3 points are all on the same line. Okay, and number 21, use any method to graph negative x plus 3y equals 6. So all you need to do is find the ordered pairs of 2 different points and then plot them and then draw a line through those 2 points. So we have infinitely many choices for ordered pairs to graph this line. But usually we try to pick things so that the process is easier rather than harder. Okay, so what method do you want to use? Slope intercept? Okay, we can use the slope intercept method. Solve the equation for y. So we start with negative x plus 3y equals 6. Add x to both sides, we get 3y equals x plus 6. And divide both sides by 3, we get y equals 1/3 x plus 2. And so we can graph this line by plotting the y-intercept. The y-intercept is 0, 2, and the slope is 1/3. Okay, that's one way to do it. Did someone else pick a different method? Well, another method is finding the X and Y intercepts. We already know what the Y intercept is. That is when X is 0, negative 0 plus 3y equals 6 is 3y equals 6, divided by 3, y equals 2. So we already knew that. We already knew the y-intercept is 0, 2. To find the x-intercept, we replace y with 0. And in this equation, replace y with 0, we get negative x equals 6, which means the x-coordinate is negative 6. Okay, either way, we have more than enough information to graph this line. So we'll plot the y-intercept 0, 2. Remember to label it. Label the point 0, 2. And a slope of 1/3. We have a rise of positive 1 and a run of positive 3. So from this point, we move up 1 and to the right 3. So this point has coordinates 3 for x and 3 for y. If you want to plot the x-intercept, you can do that. We don't really need to, but it's negative 6, 0. So my graph is not completely accurate, but it's believable. So we have more than enough points to graph that line. Okay, let's move on to the next page. Use any method to graph y minus 4x equals 0. Let's use the intercepts method. To find the y-intercept, we pick x to be 0. And then when we replace x with 0, what's the value of y? Yeah, the value of y is also 0 because y minus 0 equals 0 means y is 0. Okay, so that's the y-intercept. But what else is it besides the y-intercept? It's also the x-intercept. So just having one point isn't enough to graph a line. We need 2 different points. So we have infinitely many other choices. Just pick one that's easy. If you want to solve for y, you can. If y minus 4x is 0, then you can think of this as y equals 4 times x. So if I pick x to be 1, picking an x value to be 1 is usually a nice number to pick. And the y-coordinate is 4 times 1, or 4. Okay, so that's enough information. We just need 2 points. So there's the point 0, 0, the origin, and then the ordered pair 1, 4. So label that point 1 for x and 4 for y, and then draw a straight line through those 2 points. Okay, the next problems are have to do with determining if two lines are perpendicular or parallel. So on number 23, this says use slopes to determine if the two lines are perpendicular. So if we just write each of those two equations in slope-intercept form, then we can tell by looking what the slopes of the lines are. So for this equation on the left, negative 7x minus 3y equals 1, we'll solve this equation for y, which means we'll have it in slope-intercept form. So begin by adding 7x to both sides, so we get negative 3y equals 7x plus 1. Then divide every term on both sides by negative 3, we get y equals negative 7/3 x minus 1/3. And we can see that the slope of this line is negative 7/3. Now we'll solve the other equation for y. I'll begin by writing negative 3x minus 7y equals 3. So add 3x to both sides, we get negative 7y equals 3x plus 3. Then divide every term on both sides by negative 7. We get y equals negative 3/7 x minus 3/7. The slope of this line is negative 3/7. So are the two lines perpendicular? No, they are not. Even though the slopes are reciprocals, they are not negative reciprocals of each other. So the two lines are not perpendicular. The lines are not perpendicular. Okay, the next problem is the same directions, just different lines. Use slopes to determine if 3x plus 4y equals negative 9 and 4x minus 3y equals 5 are perpendicular. So we'll do the same thing. 3x plus 4y equals negative 9. Solve for y. So begin by subtracting 3x from both sides. And we get 4y equals negative 3x minus 9. Then divide every term on both sides by 4. Y equals negative 3/4 x minus 9/4. The slope of this line is negative 3/4. Then the other line is 4x minus 3y equals 5. Solve for y. So first subtract 4x from both sides. We get negative 3y equals negative 4x plus 5. Then divide every term on both sides by negative 3. Negative 3y divided by negative 3 is positive 1y, or y. Negative 4x divided by negative 3 is positive 4/3 x. And then 5 divided by negative 3 is negative 5/3, so we write minus 5/3. The slope of this line is positive 4/3. Hey, so are those two lines perpendicular? Yes, they are. The slopes are negative reciprocals. So the lines are perpendicular. When they intersect, they form right angles. Okay, so we don't even have to graph them to determine that they are perpendicular because their slopes are negative reciprocals. Okay, number 25, similar type of problem, just this time we want to use slopes to determine if negative 6x plus 4y equals 3 and 3x minus 2y equals 2 are parallel. If two lines are parallel, they have the same slope. So we'll rewrite each of the two equations in slope-intercept form. So this is perhaps getting to be monotonous, but that's okay. It just reinforces what you're learning. Solve for y. First add 6x to both sides. We get 4y equals 6x plus 3. Then divide every term on both sides by 4. We get y equals 6 over 4x, which simplifies to 3 over 2x. And then 3 divided by 4 is plus 3/4. And the slope of this line is 3/2. The other line, 3x minus 2y equals 2. So subtract 3x from both sides. We get negative 2y equals negative 3x plus 2. Then divide every term on both sides by negative 2. Negative 2y divided by negative 2 is positive 1y, or y. Negative 3x divided by negative 2 is positive 3/2 x. 2 divided by negative 2 is negative 1, so we write minus 1. And the slope of this line is also 3/2. And two lines that have the same slope and different y-intercepts are parallel. So parallel lines. Maybe the problem number 26. Suppose capital R equals 0.575 times capital K plus 42, where capital R is the number of dollars earned by driving K kilometers. Find the units of the slope. Okay, we're used to thinking of slope in terms of X and Y. But we're not using the variables X and Y, we're using the variables K and R. So think about what this equation would look like if we were using X and Y. We would normally write it as Y equals M times X plus B. So instead of X, we're using K. So that will be our first coordinate, and instead of y, we're using r. And so the slope of a line that passes through two ordered pairs, K2, R2, and K1, R1, the slope, instead of y2 minus y1, it's r2 minus r1, and instead of x2 minus x1, it's k2 minus k1. So what's the units for capital R? That is given in the problem. It says R is the number of dollars earned. So the units for the numerator are dollars. And the units for K are kilometers. So the units for the slope are dollars per kilometer. So in Canada, when they drive, their distances are measured in kilometers. So those are the units for the slope. Okay, that's all there is to that problem. Okay, on the next sheet, problem 27. Find an equation of the line that passes through the point with ordered pair -3, 2, and another point with ordered pair 2, -6. Okay, this says find an equation, so it doesn't say what form to put it in, so we have some leeway on deciding what form to put it in. But we do need to know the slope, and since we have two different points on the line, we can use the slope formula. So the slope formula, if our line is in the xy plane, and that's what we're going to assume, the slope formula is m equals y2 minus y1 divided by x2 minus x1. So I'm going to, in the numerator, I'm going to write 2 minus -6. 2 minus -6. And in the denominator, I have to write -3 minus 2 to be consistent with my choice in the numerator. And then we do the arithmetic. 2 minus -6 is 2 plus 6 in the numerator. In the denominator, -3 minus 2 is -5. And so we get a slope of -8/5. Okay, we can write a point slope form equation by picking either of the two ordered pairs that are given. It doesn't matter which one we pick. Okay, so I'll pick the left point for my x1, y1, and then remember, I'll remind you of the point slope form. Point slope form is y minus y1 equals m times the quantity in parentheses x minus x1. Okay, so I'm picking the point where the x1 is -3 and the y1 is 2. So y minus y1 is y minus 2. The slope is -8/5, so I write -8/5 times in parentheses x minus -3. So we should simplify the x minus -3 part at least. So y minus 2 is equal to -8/5 times the quantity x plus 3. Okay, so as I was saying, since no specific form is asked for, this is a satisfactory answer for this problem. And as I already mentioned, we could also have chosen the other point, 2, -6, to get an equation for the same line. When they're in point slope form, they look different, but if you solve each of the two equations for y, then they will be identical. So if you haven't proven that to yourself, it's probably worth doing sometime. If there's time, we can come back to that, and I'll show you that the two lines really are the same line, regardless of which point we pick for the point slope form. Okay, the next one, number 28, this is a little bit easier than the one we did because the slope is already given. Find an equation of the line with slope -5/3 that passes through the point whose ordered pair is 9, -15. So we'll just use the point slope form again. My x1 is 9 and my y1 is negative 15. So y minus y1 is y minus negative 15. And that's equal to the slope, negative 5/3, times the quantity x minus 9. And we want to simplify things like this. Y minus negative 15 should be simplified to y plus 15. And let's go ahead and write this in slope-intercept form, even though the directions don't ask for it. So we distribute multiplication through x minus 9 by negative 5/3, and we get negative 5/3 x. And a negative times a negative is a positive, so we're going to write plus 45/3. And then we'll subtract 15 from both sides, so we get y equals negative 5/3 x plus 45/3 minus 15. Well, there's a couple of ways we could proceed, but I'll just simplify 45 divided by 3 first. What's 45 divided by 3? Yeah, it's 15. So I'm writing more than is really necessary, but plus 15 minus 15 is 0. So our equation is y equals negative 5/3 times x. That's the equation in slope-intercept form. So what do you know about this line, y equals negative 5/3 times x, besides the fact that the slope is negative 5/3?
Its y coordinate would be 0.
Yeah, the x-intercept and the y-intercept are the same point, 0, 0. So this line, the graph of this line passes through the point 0, 0. Do you see that? Because when x is 0, y is negative 5/3 times 0, which is also 0. So a mini graph, the point 0, 0 is a point on the graph. And the slope is negative 5/3, so a rise of negative 5 moved down 5 units, and then to the right 3 units. So this ordered pair is 3, negative 5, and passes through those 2 points. We could also just use the slope-intercept form. Negative 5/3 x is the same as negative 5/3 x plus 0. So plus, if you think of it that way, plus 0 means the y-coordinate of the y-intercept is 0. But the x-coordinate of every y-intercept is also 0. So we have the ordered pair 0, 0 on that graph. Okay, number 29. Find an equation of the line that's perpendicular to 5x minus 4y equals negative 3 that passes through the point 5, 3. So we want to find an equation of a line that's perpendicular to this line. So the new line has to have a slope that's the negative reciprocal of the slope of the given line. That means we have to find the slope of this given line, and then whatever that slope is, we compute the negative reciprocal, and that will be the slope of the new line. Okay, so over here, we'll find the slope of 5x minus 4y equals negative 3, we'll just put it in slope-intercept form. So subtract 5x from both sides, then divide every term on both sides by negative 4, and we get y equals positive 5/4 x plus 3/4. The slope of this line is 5/4. So for the perpendicular line, what's the slope? Yeah, the perpendicular line will have a slope that's the negative reciprocal of 5/4. So the slope of the new line that's perpendicular is negative 4/5. Okay, and this line that's perpendicular to the given line, we're told it passes through 5,3. So I'll just write x1, y1 is 5,3. And then we write the point slope form. Y minus 3 equals the slope of that perpendicular line, negative 4/5, times the quantity x minus 5. Okay, the directions don't say what form the equation should be in. So this is a satisfactory answer if you want to leave it in point slope form. Just read the directions, and if it asks for slope intercept form, then there's a couple of steps left when solving for y. Okay, the next problem, this time find an equation of the line that's parallel to negative 4x plus y equals negative 5 that passes through the ordered pair negative 5, 1. So we remember that two lines are parallel if they have the same slope. Okay, so we want to find the slope of the given line, and whatever that slope is going to be the same as the slope of the line that's parallel to it. So we'll begin with negative 4x plus y equals negative 5. Solving for y, we just add 4x to both sides. Y equals 4x minus 5. And the slope is 4. If you want, you can think of that as 4 over 1. But we're just going to use 4. And the parallel line will have the same slope. The line that's parallel has the same slope of 4. And we're told that that new line passes through the point negative 5, 1. So we'll begin with the point slope form. So y minus the y coordinate, y minus 1, equals the slope 4 times x minus negative 5. And simplify the x minus negative 5 to x plus 5. Okay, so that's a perfectly fine answer if the equation doesn't have to be in a particular form. But let's go ahead and put it in slope-intercept form. So y minus 1 equals 4x plus 20, then add 1 to both sides. We get y equals 4x plus 21. Well, on the expanded version, I didn't include the graphs. I did on the first one that I sent. These are the 3 graphs. So this graph on the left, find an equation for this line. So it passes through the points negative 3, negative 1, and 2, 2. So we'll remember that. The ordered pairs are -3, -1, and 2, 2. And then we'll use the other paper, the ordered pairs for that line on the left, -3, -1, and the ordered pair 2, 2. Okay, so we need to find the slope. Using the slope formula, we get m equals, well, in the numerator, I'm going to write 2 minus -1, 2 minus -1, and in the denominator, 2 minus -3. And 2 minus -1 is 2 plus 1, and 2 minus -3 is 2 plus 3. So the slope is 3/5. And then we can use either of those two ordered pairs to find an equation. So I'll use the ordered pair of 2, 2. So y minus 2 equals 3/5 times x minus 2. So that's an equation of that line on the left. Well, I can graph the second line easily enough. So this line passes through the points 2, 1 and 0, 1. It's a horizontal line. So what's the equation for this line?
Y equals 1.
Yeah, y equals the y coordinate 1, because every point on this horizontal line has the same y coordinate of 1. So the equation for that horizontal line is y equals 1. Okay, the third line So the third line is vertical, and it passes through -2, 1. It also passes through the point -2, 0. So you notice that every point on that vertical line has the same what?
X coordinate.
Yeah, each point has the same x coordinate of -2. So the equation for that vertical line is x equals -2. Okay. So going back to one of those things I said I would perhaps do, if I can find it. Okay, so I'll just have a few minutes, so I'll just go rogue. I don't know. A line passes through the points whose coordinates are 6, 6, and -10, -7. So what we want to do in this little exercise is find two point slope equations for the line. And then show that the two lines are exactly the same, which you know has to be true, but this is just a little exercise starting out with the point slope equations involving the ordered pair 6, 6 and the ordered pair -10, -7. And then after solving each of those equations for y, you'll see that they are identical. Okay, so then show that the two lines are the same. Okay, so if a line passes through the points 6, 6 and -10, -7, first we find the slope of the line. So in the numerator, we can write 6 minus -7. And in the denominator, 6 minus -10. In the numerator, 6 minus -7 is 6 plus 7. In the denominator, 6 minus -10 is 6 plus 10. And so the slope is 13 over 16. Are we all in agreement? So one of our point slope equations will involve the ordered pair 6, 6. So we'll write y minus 6 equals 13/6 times x minus 6. Then we'll write a point slope equation using the other ordered pair instead, -10, -7. So this time we get y minus -7 equals 13/6 divided by x minus -10. And then a little bit of arithmetic, y minus -7 is y plus 7, and that's equal to 13 over 6 times the quantity x plus 10. Okay, if you just look at those two equations, we can see that they have the same slope of 13 over 6, but it's not entirely obvious that the two lines are exactly the same. So let's rewrite each of those in slope-intercept form. So we'll start on the left. We'll distribute multiplication by 13 over 6. So 13 over 6 times x is 13 over 6 times x. And then minus 13 over 6 times 6, 13 over 6 times 6 over 1. So this is going to simplify to minus 13. So I'll rewrite this. Y minus 6 equals 13 over 6 minus 13. And then we'll add 6 to both sides. And whoops, I need the variable x in there. Add 6 to both sides. We get y equals 13 over 6x minus 7. This is the slope-intercept form. So do you think it's going to work out for us? So on the other equation, distribute multiplication by 13 over 6. So we get 13 over 6x, and then plus 13 over 6 times 10, that's 130 over 6. This can be simplified to 65 over 3. So we might as well do that first. Y plus 7 equals 13 over 6x plus 65 over 3. And then we're going to subtract 7 from both sides. So we get y equals 13 over 6x plus 65 over 3. We're going to subtract 7. So that means we want to subtract 21 over 3, right? So something went wrong somewhere.
Your slope is 13 over 16, not 13 over 6.
Oh. Yeah, it would help if I used the right slope, wouldn't it? 13 over 16. Okay, well, my demonstration, we're about out of time. So I have time to rewrite the equations the way they should be. So y minus 6 equals 13 over 6 times x minus 6. And then the other one, y plus, I did it again, 13 over 16. Something's wrong with me. So the other one is y plus 7 equals 13 over 16 times x plus 10. Okay, so work on those. And even though I'm incompetent, you can still verify that that's true. Okay, so that's about all the time we have today. You're Austin, right?
Yeah.
Okay, have everyone.